Grade 12s, I post videos showcasing the work of the world's brilliant minds. Please subscribe and press the notification button. There is less than 5 days before the final mathematics paper 1 for grade 12. I sense a disturbance in the force. Your November paper 1 exam will have question 1 focusing on algebra. In these algebraic questions, they will ask you to solve for x, firstly by factorization, secondly by using the quadratic formula, because they give us a hint here to say correct to 2 decimal places. You will also solve for x by squaring both sides. Then you will have a quadratic inequality. The second question group of questions that you will have will be solving simultaneous equations, where you solve for x and y at the same time. You'll be solving this equation and that equation at the same time to find the values of x and y. This question will develop into a quadratic equation when you solve it. There is always a question that will be put at the end as the last question of question 1, where they will give you a tricky question. This question requires you to know knowledge of exponents, the nature of roots, or anything along those lines. It tests your ability of mathematics for the 12 years of your schooling. We'll begin with question 1.1, where we solve for x. So we have question 1, then we're doing 1.1, 1.1.1. They say here we have x squared minus x minus 12 is equals to 0. In order to solve this question, the first thing that you need to do is to find the factors of 12, such that when you combine those factors, either adding them or subtracting them, they then give you minus x. So the factors that come to mind is 3 times 4, because they give me 12. But to add these two numbers so that they give me minus x, minus 1, so to speak, it means my 4 should be negative and the 3 should be positive, because when I combine these two, I get a minus 1. This minus 1 is the x here. So this means when we factorize this, when we break this into factors, we will have 2 brackets like that, which are the factors of that. We'll have x and x here. Then we'll have a 3 here. We know it's positive. Then we have a negative 4. Then at this stage, we'll say either this factor here is equals to 0 or that factor is equals to 0. X plus 3 is equals to 0, or x minus 4 is equals to 0. Therefore, I'll take this 3 to this side. It will be negative. I'm transposing the x, so the 3, not the x, so that I have negative 3. Then I do the same here. I transpose the 4. I take the 4 and I take it this side. Remember, when you transpose, your number changes the sign. So when it gets to the side, it's going to be 4. So those are the 2 values of x. 1.1.2, they give us x squared plus 4x minus 1 is equals to 0. Here we're going to use a quadratic formula. We have x squared plus 4x minus 1 is equals to 0. Remember, our quadratic formula says if you want to find the values of x, they're going to be given by minus b plus or minus the square root of b squared minus 4ac over 2a. Now you are provided with the information sheet where there is formulas there. You can get this formula there. If you don't remember the formula, don't stress yourself. Go to the information sheet, take the formula and use it. Here we'll then have equal sign. The b, remember what we are doing here. We are saying this is ax squared plus bx plus c. So the a here is this part here is an invisible one. The b is a 4, the c is a -1. Now this means we'll have the negative from the equation. This negative will come here. Then the b we said is a 4, so we'll have a 4 plus or minus 4 squared minus 4. The a we said is a 1, is this part here. And we're saying that the c is a -1. All this is divided by 2 times a, which is we said is 1. Now at this stage, we are going to find the value of this here, right? So don't jump quickly into your calculator, because the examiner expects you to do some of these things without a calculator. But now you have to show them that you didn't use the calculator, even if you have used it. So this is going to be -4 plus or minus the root of, now here I have a 4 squared, which is a 16. Here I'll have 4 times 1, which is a 4, times -1 is going to be a plus 4. 16 plus 4 has to give me a 20. All over 2 times 1 is a 2. At this stage, you can press your calculator. You can come and say, I have here -4. I'll start with the plus. Then I put a root of 20 divided by a 2. This gives me an answer of, therefore, x is equals to 0.24, or I'm going to put a negative here. Oh, I erased everything. Let me start over again. 4 minus 20 over 2. This gives me a -4. X is equals to -4.24. Now, this is important. Maybe also if I could come here as well, just to discuss with you where you get your marks. They'll give you 1 mark for factorizing. They give you 1 mark for the correct answer and the 1 mark for the correct answer. This is where the 3 marks comes from. This one as well, it has 3 marks. They will give you 1 mark for correct substitution, 1 mark for the final answer. But it's important to show the examiner that you are following through. You are not just pressing a calculator. We then have question 1.3, 1.1.1, 1.1.1.3 that says we have a 2x squared is equals to 2 minus x. Now with this question, what we do is that the first thing that we do, we square both sides to remove the square root. Remember, what you do on the left, you also do on the right. Now, when we square this on both sides, you would remember from the laws of exponents that these 2 will come here and also come here. It will affect both the 2 and the root of x squared. When we go to the 2, it will be 2 squared, so that it gives me a 4. But when it comes here, I will have x squared 1 over 2. This is the same as x, the root of x squared. But I'm saying here now I have that 2. So these 2 and these 2 will cancel, and then I'm only left with x squared. So here we'll have the x squared is equal to. Now here we use a trick where we firstly start by squaring the 2 So I square the 2 squared, it will give me 4. Then I take the 2, these 2 here, I multiply it with these 2 here. So we say 2 times 2, then I multiply it with negative x. So this will give me 2 times 2 is 4, times negative x is negative 4x. So it means here we'll have negative 4x. Then we square the x, the negative x. We say x, negative x squared, right? We're squaring this last part here. Then it will give us a positive x squared, because we know a square of a positive number, of a negative number, is a positive number. So now we have 4x squared is equals to 4 minus 4x plus x squared. Now at this stage, I'll group my terms. I'll take this x to this side so that it will be negative x squared. Now I'm having here 4x squared minus x squared. That should give me a 3x squared. So I'll have 3x squared. Then I also take this minus 4 to this side. It will be a positive 4x. So I'll have a positive 4x. I take the 4 to this side, will be a negative 4. So I'll have a negative 4. And this will then be equals to 0 because I took everything here to that side. I don't have anything left. I have a 0 that side. At this stage, we can factorize. This looks like it's actually the standard form. It doesn't look like it's the standard form is ax squared plus bx plus c, right? Then this is something that we can factorize. Factorizing this, I'll have obviously here at the start 3x and x, because when I multiply these two, I go back to the 3x squared. Now we're going to look for the factors again of 4, so that when I combine those factors, they actually give me plus 4. So those factors are actually 2. Let me use a different pen. 2 times 2 is equals to 4. So this guy here is this guy. If I put a 2 here and a 2 here, they'll give me a 4 when I multiply them, when I multiply these two. Now we have to look at this in order for us to now determine this guy here in the middle, we have to also notice that there's a 3 here. So if we say this 3 times 2, right, we get a 6x. But when we come here and say the 2 by x, we get the 2x. Now, how can I add these two so that they give me the positive 4x? You can see that the 2 has to be negative and this has to be positive, because when I add those two, I'll get the 4x, which is this guy here. So this means the first part here should be a positive, because it's the part that gives us the 6, remember. It's the one that gave us the 6. And the second part should be a negative, because this 2x, we get it by multiplying these two. So here it's going to be a negative. Now at this stage, we have 3x minus 2 is equals to 0, or x plus 2 is equals to 0. Now this means I'm going to have 3x is equals to 2, or x is equals to negative 2. Therefore, x is equals to 2 over 3, or x is equals to negative 2. Those are my answers. Now, how this question will get marked, it's worth 4 marks. So to get that 4 marks, what they mark here is the fact that you started by squaring both sides. That guarantees you 1 mark. You wrote the standard form. You see here we have written the standard form. AX plus BX plus C, they give you a mark for that. Be sure that when you do these questions, you show those steps. These are the types of steps that you don't skip. The final answer would be 1 mark and 1 mark. That's a total of 4. The next question is on inequalities, is 1.1.4. This one here. We are given here in 1.1.4 that we have 3x squared plus 5x is greater than -2. Yes. Now the first thing to do this question is that you also write this question in a standard form, right? So we take this 2, bring it to this side, -2, bring it to this side, so that we have 3x squared plus 5x plus 2 is greater or equals to 0. Now remember, this -2 when it comes is going to be a positive. And remember, when you are transposing, when you deal with inequalities, this inequality doesn't change. It only changes when you are dividing by a negative number. Now at this stage I can see that this is my standard form. It means I can factorize. In factorizing this, I'll have x is greater than 0, and here I'll have 3x. I'll have an x here. Now you can see that the factors of 2 that we have, because we need to get the factors of 2, meaning 2 numbers that you multiply and they give you 2, right? So those numbers are 2 by 1. They'll give me the 2, right? So this 2 here is this 2 here. But we're also saying if we combine this number, we should get 5. Obviously, if you say 2 plus 1, it will never give you 5. Even if you can say, you can put a minus and say -2 plus 1, it won't give you 5, it will give you -1. But you will see that we have the 3 here that will do the magic. So you can see that if I put a 1 here, I'll have this 3 times 1, and then it will give me a 3. So this will give me a 3. So it's like it's a 3x. And I also have, so it means the 2. If I've put 1 here, it means the 2 should sit here. Then if I multiply this 2, I'll get a 2x. So I'll have a 2x here. Already you can see that these 2, if you add them, they give you a 5x, which is this guy here in the middle, what we want. So it means we have figured out that here we should have a 1 and here we should have a 2, and both of them should be positive. And this actually makes sense if I'm saying both of them should be negative, because I can see that I don't have a negative on my equation. Now when we're at this stage, you must remember that this is an inequality problem. There is no equal, well, there is an equal sign here, but there is also a greater than sign, right? So this greater than sign actually tells us that this parabola, remember this is a parabola, it tells us that this parabola, right, or this expression 3x squared plus 5x plus 2 should be greater or equals to 0. That means it should be positive. It should be a positive number. So what does that mean? That means we're looking for the values of x that will make this whole thing to be positive, right? That's why here we're not going to solve this as if we're solving for x. We are going to look for the critical values, CV we call them. So the critical values occur when these two products, 3x plus 2 is equals to 0, or when x plus 1 is equals to 0. And we know that if 3x plus 2 is equals to 0, we're going to have x is equals to -2 over 3. because I'll take the 2 to the other side, it will be negative, and then I divide by 3. Or I'll have x is equals to -1. This is what we call critical values. The critical values assist us in creating intervals, what we call intervals. So I'm going to draw a number line here, and I'll have my -1 this side, because -1 is smaller to 2/3 compared to 2/3, because 2/3, if you check here, 2/3 is about 0.67 or around 0.7, right? So it is closer to 0, and 1 is a bit far to 0. Now this means here at this stage I have 3 intervals. I have an interval here where, so what I'm saying here is that here we're looking at the values of x that are less or equal to -1. Here we're looking at the values of x that are between -1 and this is equal sign here, is less or equal to -2/3. This side we're looking at the values of x that are greater than -2/3. Now, in order to do this problem or to find these intervals, we're going to test which interval between these 3 intervals is positive. Which one is positive, right? Because we're looking for the one that is positive. So we don't know which one is positive on the 3. To know that, we're going to use our calculator and take this equation here, well, the expression, particularly this expression here, and put the values in each of the intervals of x here and see what number do we get. Do we get a positive or negative number? In an interval where we get a positive number, that's where the values of x will satisfy this inequality. Now, to do an example here, I'll start by looking at this interval here. I'll say 3, and then I'll take a number that is in this interval. So I'll go for -2, it's just closer to 3. You can take any number, right? And we square this, then we say 5 times -2 plus a 2. So I didn't put a positive here. I need to have a positive here at the bottom. So I get this interval here gives me a positive. So it means any number that is in this side will give me a positive. So it means the values of x that are in this side here, they actually satisfy this equation. They make this equation to be positive. These are the values of x. But we have to test the others, because there could be other intervals that give us a positive. Now, in this interval here, I can take a 0. I think it's the simplest to work with, because, no, we don't have a 0 in here. I'm lying. So I can take here negative 0.9 somewhere here, or negative 0.7. So I'll go with negative 0.9 and see what I get there. Negative 0.9. Then it says the values of x that are here, they are negative. If you take any value, even if you can take negative 0.9, 0.8, 0.6 is closer to this number, right? Make sure that you don't go outside of this number. I almost went out by wanting to take 0. In fact, I'll then take 0 when I'm in this interval, because 0 will be somewhere here, right? Or you can take 1, you can even take 2, because we're going towards the positive. So I'll go with 0. Is the easiest to work with. It gives me a positive. So we don't look at the number that we get, like we look at the sign. I can see that the number is 2, but I want to see if it's positive or negative, right? So this means any number that you will take that lies in here, it will give you a positive number. So it means it makes this inequality to be positive. So that means my answer, right, the values of x would be x less than 1, any number that is less than 1 or equal to 1 for that matter. In fact, that's how we draw it here. We're saying from -1, even if you can put -1, because we're saying equal sign here, meaning -1 is included, is part of the solution. So from here going to infinity, right? That's a solution. Or the other solution would be x is greater or equals to negative 2 over 3. So here we're saying any number from negative 2 over 3 up until we go to positive infinity. Another way of writing this is to use a notation where you're saying from negative infinity to 1, and I use square brackets here to say 1 is equal to, right? Is part of the solution, is included. Or I would also write this in this fashion. I'll say from negative 2 over 3, because it's included. Square bracket would mean it's included, it's an equal sign. This will move from here up until infinity. You can use this notation if you like, right? So that's how you'll do the inequality problem. The other problem that we have is 1.2, where we're given these two equations to solve simultaneously, right? With this equation, this question will have 1.2. I'll say 2x minus y minus 3 is equals to 0. I'll call this equation 1. And I'll then have my xy is equals to 5. Let me just check if I've written everything correctly. Yes. Yes, it looks right. Now here I'm going to divide both sides by an x and an x because I want to make y the subject of the formula. This will cancel, then I'll be left with 5 over x. So here it means y is equals to 5 over x, and this I'll call equation 2. Now at this stage, I will say substitute equation 2 into equation 1. So what am I saying? I'm saying that when you go back to this equation, whenever you see a y, put 5 over x. So it means here on y, we're going to put 5 over x, right? So this means we'll have a 2x minus 5 over x minus 3 is equals to 0. Then you can see that I only have the x in this equation because we have sort of eliminated the other variable, the x. Now at this stage, what I'm going to do is that I'm going to multiply by x on both sides, on all the terms on both sides. So when I multiply by x here and multiply also by x this side. So when we multiply this, remember that if I multiply by x here, the x will multiply this, multiply that, and also multiply that. It multiplies each term. So I'll multiply them one by one without writing them. Remember that this question will be long if you write all the steps. You need to save time, right? So here we'll say 2x times x. It will give me x squared. Here we'll have this times x, right? The x and the x will cancel. I'll be left with negative 5. So here we'll have a negative 5. And here we would have negative 3x because we just multiplying this by x. It will give you negative 3x. This side will be 0 because any number multiplied by 0 is 0, right? So the x times 0, it will give you 0. Now if you look at this carefully, already it's looking like a quadratic equation. So I can rearrange so that it's sitting like this. I put it in a form of ax squared plus bx plus c. This will give me a 0, right? Now at this stage, this is something that I can factorize. I can say this is equals to that, and I'll have a 2x, I'll have the x here. The factors of 5, then two numbers that I can multiply to get 5 is only 5 and 1, right? So if I say 5 times 1, it gives me a 5. So that's how we get this number here. But now if I combine these two, can I get a 3? No, I can't. But you'll notice that we have a 2 here. So if I say I multiply here by 1, right, you would see that I will have 2x, because I'll have a 2x, because, you know, 1 multiplied by any number is that number. So it means the 5 will sit here, and if I multiply this by a 5, I'll get 5x. So I'll have a 5x here. Now, can I combine these two? Can I combine these two so that I get a negative 3? Yes, I can. If I make the 5 to be a negative, then I'll end up having, if I say 2x minus 5, I'll end up having negative 3x. So now this means the first part of my, the second bracket, the second bracket should be positive 1, because remember is the one that gave us this positive 2. And definitely the 5, we get it when you put it here. So it has to be a negative 5. So here we'll have a negative 5. Now at this stage, we are at our answer where we can say x is going to be a positive 5, because it will go to the other side and it will be positive. Remember, I'm setting this equals to 0 and this equals to 0. Right? So it will be 5 over 2, because I'm going to divide by 2 at the end of the day. Or I'll have x is equals to negative 1. So now I have found the values of x. I need to find those of y, because it's the simultaneous equation. Now to find those, I'll use this equation here. I'll say from equation 2, which says y is equals to 5 over x, right? So this means I'll start by taking this value here. I'll have y is equals to 5 divide by, because this is a division here, divide by the 5 over 2, because the x is a 5 over 2. So now this means I'll have a 5 times 2 over 5. Remember that when you're dealing with fractions, if you want to solve this, you'll have to turn this to a multiplication, and then that means you have to then invert the 2, right? So that now you can see that the 5 and the 5 cancel each other. Then we are left with y being equals to a 2. You do the same with a 1, so that you have 5 over negative 1, because the x here is negative 1. Now this will give you negative 5. So our final answer would be that x is equals to 5 over 2 and y is equals to 2. Remember that when x is 5 over 2, the y is 2, is this part here. So they go together, right? Or this is how you should write your final answer. X is equals to negative 1. And when this is the case, when x equals negative 2, then the y is equals to minus 5. I want to go back to show you how they mark these questions and what is important to look at. The 1.4, I realize now that I didn't discuss how it gets marked, but let's go through it. It was worth 4 marks. So definitely the first mark will come from you writing the standard form. So you can see that the standard form is always important to write. Ax plus bx plus c. They will give you a mark for that. They will give you a mark for finding the critical values, and they will give you a mark for your final answers. 2 marks. 1 mark for the one answer and the 1 mark for the other answer. Then this will give you 4 marks. With simultaneous, they mark the fact that you took one of the equations and make made the other variable the subject of the formula. Then they mark correct substitution, that's 2 marks. So simultaneous is about 6 marks, that's 2 marks. Then they'll mark standard form. Look at this, always standard form gets marked. Whenever you're dealing with a quadratic equation or inequality, ensure that if you have the standard form, you write the standard form. Actually, it's here, you write the standard form. Then we have 1, 2, 3 marks. Then they'll give you 1 mark for simplification because it's a long question, this one. So they appreciate the fact that you've been simplifying, right? So they also give you 1 mark for, not here, for the final answer. The fact that you grouped these two, you get 1 mark. So we have a total of 1, 2, 3, 4, 5, 6 marks. That's how your simultaneous will get marked. Let's jump to the last question of question 1. In this question, they say to us, if the sum of the square of m and n is equal to the product of 2029 and 2031, where m and n are real numbers, show that the root of the sum of the square of m and n and 1 is equal to 2030. You know, as I'm reading this question, I think you also asking yourself what's going on. You know, these questions will always be there. There will be that one tricky question before you get out of this question 1. Here's my advice with these questions. Spend your question 1 doing the questions above. And when you get to this question, if you feel like it's giving you problems, when you read it, you can see that you don't know where to start maybe. I'll advise you to skip this question and do all the other questions that you are comfortable with, that you can manage, that you know that you can manage, because they'll carry a lot of marks. Don't spend more than 10 minutes or even 5 minutes on this question, because this question sometimes it can hold you for even 30 to an hour. It won't be wise for you to stay on this question for 3 marks. You will fail the exam. Go take marks elsewhere. Even if this question you end up not being able to do it, you can lose these 3 marks. It's not going to affect your total. I mean, if you can take the marks on other questions in the question paper, then you can still get a distinction or even pass with flying colors. So I advise that if you don't know what to do here, you skip. But let's break this one down. So as we are preparing and practicing for the exam. Now, here you can see that we're squaring 2 numbers and adding them. So is the sum of the square of 2 numbers, right? And they tell us that these 2 numbers, m and n, are real numbers. That means these numbers here, they are all the real numbers. They can be positive, negative, they can be decimals, so they are rational and irrational. And that makes sense, because if I put a negative number here and I square it, and I put maybe a negative number here and I square it, it's possible for me to get a number that looks like that. If I put a number that has a square root here and I square it, and maybe do the same here, it's possible that I can get a number like this because there's a square there. So it makes sense for these numbers to be real numbers. Now, to begin this question, what we're going to do is that we are going to take the sum that we are given, which is 1.3. I want a blue pen here. 1.3. We will take the m squared, the sum of the square of m and n is equals to 20, 29 multiplied by 20, 31. Because I see squares here, I'll try to bring a square also on the right hand side, right? And how I will do that is that I'll just write this as it is, and I'll say here, how about I do the difference of the product of these two numbers. So how about I write this as 2030 minus 1, because I know that 2030 minus 1, it will give me 2029. But also here, I want to have this 2030 as well. But to get there, it means I have to add 1, right? Because if I add 1 on 2030, I get, I didn't want to write my 1 here. I have 1 here. Can I write this properly? Because it's very important to understand this question. If I add 1 on 2030, I'll get 2031, right? So this is the product of the product of the difference of two numbers, right? That sounds familiar and it looks familiar to me. This looks to me like something like this. It looks like a plus 1, a minus 1, right? We know that this is a difference of two squares, right? Because we have the same numbers. This could be a here, and then we have 1 and 1. The other one is positive, the other one is negative. Now it looks like we're going somewhere by that approach. So this would mean I'll keep my 2030 squared, then I'll have a negative 1. It should take me back here. It's a difference of two squares. I mean, if you multiply this by this, it will give you that. This by this, it will give you a positive 2030. This by this, a negative 2030. Positive 2030 minus negative 2030 is a 0. And then if you say 1 times this, you'll get a negative 1. You know a difference of two squares, right? Now at this stage, I can see that this looks like what they want us to prove. Do you see here that we have these two m squared and n squared and a plus 1? So I managed to have a 1 there and a 2030 as well. So immediately I can see that this 1, if I take it to this side, is going to be a positive. So that I have m squared plus n squared plus 1 is equals to 2030 squared, right? But I want it in a form that it has a square root, right? So this means I can put a square root this side, it will be plus or minus, and I put a square root as well this side, right? To remove that square root. So here we will have 2030, but this side will have the root of m squared plus n squared plus 1. Notice that I only took the positive answer because, so this will be my final answer, hence proved. I took the positive here between this and this because there is no way in which you can square these two numbers if they're real numbers. You can square these two numbers here. When they multiply each other, you square them so that they give you a negative number. This number here has to be positive. You can see that it's a positive 2030, right? So it always has to be a positive. It cannot be negative. And that's how you solve this problem. And basically that's what you should expect for question 1.